Hello everyone, welcome to Instrumentation Academy. In this video, we will discuss some basics of control system. First, let's discuss what is a system. A system is an arrangement of different components that act together as a collective unit to perform a particular task. A system consists of three basic elements, namely input, process, and output. The output is the specified function performed by the system. The system itself produces the output as a result of an input being supplied to it. The system changes the input using a series of mechanical or chemical operations to produce an output. This series of actions is called the process. Let's consider that a power source is connected to a bulb. Then the bulb glows. This can be considered as a system. Here, the input to the bulb is current, while the output is light. The lamp filament converts current to light, which is the process. Now consider that we need to control the bulb. That is, it should be on when we require light, which means we need to control the output of the system according to our wish. Controlling the system or control system means to force or direct a system to give a specific output without considering whatever be the input. This is the simple block diagram of a control system. In this we can see two blocks. One is a controller block and the other is the system block. In control system, the input is given to a controller and the controller generates a control signal which is then forwarded to the system block. The system block receives the control signal and processes it properly and finally gives the desired output. For effectively controlling a process, we need to know how the input we are planning to use will affect the output of the process. For this, a mathematical model of relationship between the chosen input and the output of the process is made. The control system can be represented with a set of mathematical equations known as mathematical model. These models are useful for analysis and design of control systems. Analysis of a control system means finding the output when we know the input and the mathematical model. Design of control system means finding the mathematical model when we know the input and the output. Most commonly used mathematical models are differential equation model, transfer function model, and state space model. Control system engineering is the engineering approach taken to understand how the process can be managed by automation devices and to implement such into operation. Control engineering is not limited to any engineering discipline. It is equally applicable to aeronautical, chemical, mechanical, environmental, civil, and electrical engineering. Depending on the configuration, there are mainly two types of control systems: open loop control system and closed loop control system. Open loop control system. A system that does not have any feedback from output is known as open loop control system. This is the block diagram of an open loop control system. In this system, based on the required output, input is given to a controller and the controller generates a control signal. This control signal is given as input to the process. Based on the control signal, appropriate processing is done and the output is generated. Now the system assumes that this generated output is the desired output. As there is no feedback path from output, input is independent of output. So this system is also known as non-feedback system. As this system does not have any feedback from output, the system cannot decide if the required output was attained or not. Open loop control system is also known as manual control system. Now let's see an example of open loop control system. A digital camera is used to take a photograph, which is then transferred to a computer where processing of picture is done. Now a printer is used to take a printout of this picture. As there is no feedback from output, no action can be taken to improve the quality of the picture. Closed-loop control system. A system in which the controlling action of the controller is dependent on the output is known as a closed-loop control system. This is the block diagram of closed-loop control system. This system has an error detector that produces an error signal, which is the difference between the input and the feedback signal. This feedback signal is obtained from the output. Instead of direct input, this error signal from the error detector is applied as input to the controller. Now the controller produces the control signal which controls the process. By this way, the output of the control system is adjusted automatically till we get the desired output. Hence, open-loop control systems are also called automatic control systems or feedback control systems. Now let's see an example of closed-loop control system. In this example, a control system maintains water level in a storage tank. The system performs this task by continuously sensing the level of water in the tank using a level transmitter. The output from the level transmitter is sent to a level controller. The level controller then compares this feedback signal with a desired tank level to produce the required control action that will position the level control valve as needed to maintain the desired level in the tank. So the level in the tank is maintained at a desired level automatically. By this we come to the end of this video. If you like this video, please support us by subscribing our channel. Thank you.